Okay, we're on video 2 of the air conditioning and electric heat simulator board. Today we're going to look at the terminal board, and we're also going to look at the digital programmable thermostat. The terminal board itself is a luxury of the system. We don't have to have it. It's not an operating control. It's not a safety control, but it gives us a place of termination, simplifies it, so we don't have to use so many wire nuts, and also it allows us to have a place of troubleshooting. Just remember that you don't always have those, and that it could be all wire nutted together. But typically you have your 24 volt power and your 24 volt common here where your transformer is coming into the system. And then you have, we're going to use R for the power wire if we're color coding, which we want to, but don't depend on it. We're going to use blue for the common wire going out to the thermostat, and we're going to use G for the fan circuit. That's your green wire. We got yellow for our Y circuit, which is our cooling wire circuit, and we have white, which is our W circuit, which is our heating circuit going out to the thermostat. So there's 5 wires going out to the thermostat. And if we look at the thermostat, it is a digital programmable thermostat, and you can program it here from the front. We're not going to go into the programming at this time, but we're going to look at the general functions of the stat. You have the fan on, fan auto. We're typically going to use that in the fan auto position. If your fan on is on, the fan will run continuously. And we have your off and your cool or your heat, depending on the mode you're going to be on. You can pull the thermostat off the subbase. First thing you want to do when you're setting up the system is look at the dip switch here on the back. If you're using an electric heat or heat pump, we're going to put the switch in that mode, or if you're using gas heat or oil heat, we'll flip it to that mode. Typically oil heat is up north, and we don't have any here in this area. This thermostat can be run off of either 24 volt power or DC voltage from the 2 AA batteries. I like to use the 24 volt power also, even though if you look here, the common wire is from 24 volt is optional. It doesn't have to have it, but I like to have it in case my batteries go down. I still have function, and also I do like to use the batteries in case we lose power. We still have the display and the program intact. Let's talk about the actual terminals of the thermostat and their function here. You see where your red wire's coming in here, that's your 24 volt power coming in. It's got a jumper going from RC to R. That's your power wire coming into the thermostat. You got your 24 volt common, which is your blue wire. And then you have your W circuit, which is your heating circuit, with the white wire going back out to the system, calling for heat. You have your Y circuit, which is your cooling wire, and we're using a yellow wire for it. That's going back out to the terminal board for the cooling contactor. And we have the G terminal, which is your fan circuit. Now the operation of this stat is if you're in the auto mode and cooling setting, and you call for cooling, or the temperature in the house rises above the set point, it will close the power wire internally in the stat to the Y circuit and the G circuit, calling for the cooling contactor and the fan relay, bringing on the indoor blower motor, which R will close to those 2 wires. They will come out here to the terminal board and complete the circuit in the cooling mode. The G circuit goes out to the fan relay, and the Y circuit goes to the cooling relay. In the heating mode, you're going to close, R is going to close to the W circuit, which is heating, come out here to your terminal board, which is going to be connected to your heating relay. I like to look at this as 2 wires, even though we have 5 going out to the thermostat. I like to look at it from a troubleshooting standpoint of 2 wires, the 24 volt wires going out to the stat, and the actual 3 wires coming back, which is your W for your heating. If you're in the heating mode, R is taking a ride on W back out here to call for heat to finish the circuit. If we're looking at cooling and we're calling for cooling, then R is going to take a ride on Y and G and come back out here. So I got two wires going here, 24 volts. The 24 volt hot is going to take a ride back on these other three wires depending on the call for cooling or heating. So if you put your digital multimeter here across the 24 volt hot and your 24 volt common, you're going to read 24 volts. Now if you was checking to see if you're making a call for cooling on here, you would leave one leg of your meter here on the 24 volt common, and you would put the other leg here on the G to see if you had 24 volts coming back, or the Y for on the cooling, because G and Y both are energized in the cooling mode. They are the same wire as the hot wire. The 24 volt hot goes out to the thermostat, and that's as far as it goes. When the thermostat calls for fan, it will take a ride back on the G circuit, which completes the power wire back to here to go to the fan relay. If we're calling for cooling, then we're going to have power. The R wire is going to take a ride on the Y cooling circuit and the G circuit. So we would actually have 24 volts from the 24 volt common here to the G circuit, or 24 volt common to the cooling circuit. And it'd be the same way in the heating mode. If you're calling for heating, then your R wire, it stops here, but when the thermostat calls, it closes the switch to the W circuit, comes out here and energizes W. G for the fan circuit is not energized in the heating mode. The heating relay operates the heating elements and the fan in the heating mode.